Welcome to this video. My name is Mark Scythian. The date today is May 19th, 2025. So this video lecture is going to focus on light bulb resistance across a DC circuit, specifically a DC series circuit. So we have 4 light bulbs connected in series, drawing voltage, current, and power from a 12 volt DC battery, and each light bulb has its specific wattage rating. So we can start by first solving the problem, which is to calculate each light bulb's resistance in ohms. So the first step is to calculate the total wattage. So across any series or parallel electrical circuit, we can just accumulate and add together the independent or component wattage per item. So we just add these together. So this circuit has 225 watts of power draw across the 4 light bulbs. The second step is to solve for the circuit current. And note that we have a series circuit, not a parallel circuit. So this means the current will remain constant across the series circuit. The amps will remain constant at each light bulb. So we can access the DC electrical power formula in watts. P is equal to I current in amps times E volts in voltage. We can then solve for I, which is P divided into E, or power into voltage, to solve for the current. So we can simply just divide the 225 watts total power into 12 volts total voltage, and we calculate 18.75 amps. So we'll write that in there. So the current is constant to each light bulb, equal to 18.75 amps. The next step is to solve for the voltage drop into each light bulb. So the voltage will not remain constant, only the current will remain constant in a series circuit. So each light bulb will have a different voltage. So we can again use the DC electrical power formula measured in watts for DC circuits, which is just simply the current times the voltage. But instead, this time we're going to solve for the voltage. So we have then the power in watts at each light bulb divided into the current at each light bulb, but because the current is constant, we can just repeat the 18.75 amps at each light bulb. So we'll label each light bulb 1 through 4. So upon making these calculations, we calculate each light bulb's individual voltage drop or absorption into the circuit, into each light bulb's circuit. So here we have light bulb 1 through 4 respectively is 3.2 volts, 1.6 volts, 4.8 volts, and 2.4 volts. So then the next step is to solve for resistance at each light bulb. So we can use Ohm's law solving for voltage in DC circuit. So that's the voltage is equal to current times resistance. So voltage in DC circuits is current in amps I times resistance in ohms R. So this time we will solve for resistance instead from Ohm's law. So this is the voltage divided into the current. So for light bulb number 1, its resistance is 0.17 ohms. Light bulb 2 has 0.085 ohms. Light bulb 3 is 0.256 ohms. And then light bulb 4 is 0.128 ohms. So now each light bulb's resistance value has been solved. So follow these 4 steps to solve for light bulb resistance in DC series electrical circuits. So thank you for watching this video and have a great day.